Hi, everybody in the audience. Yeah, it's great to actually see people. That's pretty cool. I'm doing my best today. I wish I could be with you, but I've got my most tropical shirt on that I could possibly have. But anyway, let's get to what we're here to talk about today, and that is functional web apps. And the question is, are dynamic web apps actually on a rage-filled revenge tour, not unlike John Wick? Well, no, not exactly, but we are seeing the kind of over aggressively moving to static site generated solutions. We're seeing a bit of a backlash against this, but regardless, I'm getting ahead of myself. Who am I? I'm Simon MacDonald. And if you have any questions about this talk, or you ever want to get a hold of me at MacDonaldST, whether it is on Twitter or Instagram or pretty much anywhere on the web, that's where I'm available. Long story short, that was my Unix user ID from university. So it's available everywhere because no one else would actually choose such a stupid username. But, you know, what are you going to do? I've had it for 15 years now. So what do? I'm the head of developer relations for a small startup called Begin. Basically, what Begin does is try to make your life a lot easier when you're dealing with AWS. Hands up in the crowd. Anybody ever log into the AWS console? Okay, so apparently all of those people in that room have not logged into the AWS console. It's cool. So anyway, with the AWS console, if you've logged into it, you're pretty much given 200 things that you have to choose from, and it's really a lot to learn. So with Begin, we try to give you a set of good options that you can just get started building web applications right away. So anyway, that's really the last time that I'm going to talk about Begin, and I'm not really trying to sell you anything. I'm just trying to show you a different way to build web applications that we find pretty useful. So digging into things, what is a dynamic web app? Well, it's something that is not static. All of the HTML is rendered on demand, but it's not just limited to the HTML. It's required for building any kind of APIs. So if you have just anything that returns JSON or any other kind of format, that is a dynamic web app as well. So your API servers are considered dynamic web apps. So any kind of responses like that. It's generally backed by a database. So that's where you kind of get into that full stack side of things. Having a backend database for this stuff is absolutely crucial. And we'll get into why a little bit later. So when it comes down to it, you can see that in the typical three-tiered architecture, we're breaking up everything into our separation of concerns. Sorry, excuse me. Sometimes this is called the model view controller pattern. Or another way of thinking it is separating that your presentation layer from the application, from your presentation layer, the UI code from the application or business logic code, and separating it from your database. So splitting out the code in this fashion allows you to separate frequently changing the user interface layer from the more stable business logic layer, or at least I hope your business logic layer is more stable than your UI layer. As well, this allows you to abstract your database from business logic, allowing you to completely change your database if you ever need to. So quick question, anybody ever completely change their database? Anybody at all? Throw some hands up there. No? Okay. Basically, if you've ever had to completely change out your database layer, you've only ever done it once because it is a huge pain in the butt. So if you properly create your application so that the database layer is abstracted away from the application logic, it makes life a whole lot easier. So having this kind of three-tiered architecture is super useful for something like that. Typically, hey there. Anybody? All right, just gonna mute for now. So yeah, sorry, where was I? Yeah, so typically you'll see that moving to a different database layer when you're switching from something like AWS to Microsoft, so that you completely have to change everything up because your CTO has got a better deal with Microsoft and they decided to change the entire thing. So this entire setup popularized the front-end, back-end data engineer roles in tech. And honestly, I think that's a little bit goofy because we can be full stack engineers. We just don't need to specifically look at one of those different areas. All right, moving on, the traditional dynamic web ecosystem. There are a lot of different players, Rails, Django, Express, WordPress, and Laravel. I don't know if I ever say that right, but I'm doing my best on that. And so what we're going to do is take a look at one of those in particular, and that is the Rails logical architecture. So let's use that as an example because it is literally MVC. We have the active record as the model or data layer. We have the action view as a presentation layer, and the active controller as the business logic. So this is what the logical view of the application looks like, and it's how we split up the code in our project as well. So it makes it very easy when you're building a Rails application in order to figure out exactly where certain pieces of the code should go. That's very well broken up for you. Now, looking over at the Rails physical architecture, it's deploying it is a lot different than what our source code looks like. So this is a typical deployment of a 3-tier architecture, albeit I've simplified it somewhat as I've omitted some bits for clarity. But this is roughly what happens where we load balance a fleet of servers in order to share the traffic. So these servers will typically talk to a backend database or databases for data and caching. And so all of those bits can scale horizontally ad infinitum in theory as well. Where things get kind of messed up is when we start to deploy, as our logical architecture only goes into one of these web servers. So then we just repeat it as many times as we need it in order to scale for traffic. So the more traffic we have, the more web servers and the more deployments we need to make. And if anything goes wrong, then we need to roll back that many servers, and that's kind of a huge problem. The other big problem is there's many parts of the architecture that are not in source code control. So you can see in the slide that basically anything in that dotted blue circle is what's actually in source code control, but lots of other bits aren't. So places like Heroku took care of that for you as kind of the infrastructure as no code. If you wrote your application in a certain way, all the other parts were taken care of for you, but over time, it didn't scale so well. So tools like Ansible, Puppet, and Chef came around. These configuration manifest tools would allow you to check in the manifest or the configuration file that describes your infrastructure for you. This eventually evolved into something which is called infrastructure as code. And it's not unlike how you would check in a package.json to specify your core dependencies for a node application. Infrastructure as code allows you to declare your cloud dependencies in something like Terraform or CloudFormation. Now we don't need to wonder how to reproduce this environment or what gets deployed because we have something checked into source code control. We can roll back to a known good version and be, satisfied that it's going to work the same as what it did the last time that particular patch was deployed. So looking at the traditional dynamic web app problems, few things. The logical 3-tier architecture is not the same as the physical architecture. So that makes life really difficult for you when you're trying to deploy things when your infrastructure isn't versioned. And I think if I convince you of one thing in this talk today, it's that if you're not using infrastructure as code right now, you really should be looking into it. It's super useful. So again, difficult to deploy when your infrastructure isn't versioned. Slow rolling out when you're doing deployments, and servers are actually pretty difficult to scale horizontally. It's a huge pain in the butt. And when it comes to dynamically generating HTML, that can be really slow because traditional databases in this type of model are pretty slow. We've gotten a lot better with a lot of the cloud-based databases, and I will talk about that later. And the maintenance costs are absolutely huge. It's not fun patching and updating and debugging all this sort of stuff. And then you can get some drift where what you actually have deployed into your production environment is not exactly what's either checked into source code or just basically different versions of the same application are running on different servers. It just gets to be a pain in the butt, and you don't want to have to deal with stuff like that. And then things like background jobs for performance can be a bit clunky because they're not generally included as part of this kind of architecture. So things like pub sub or queues or cron jobs, they're added on after the fact. So it can be a little bit again, a pain in the butt to add this stuff in. All right. So those are some kind of problems that we can run into with the traditional dynamic web app approach. And as I said, if I teach you one thing today, and that is to look into infrastructure of code, especially if you're not using it, I read way too much. If you can actually see me on the screen, there's bookshelves on either side, which are completely filled. And there is about 15 more bookshelves downstairs in the basement filled with books. Anyway, I read a lot. So when I give a book a 5-star recommendation, that is something. This book by Forzen, Humble, and Kim is absolutely fantastic. If you've read The Phoenix Project, also by Gene Kim, that is a fictional account of a startup, or sorry, not a startup. It's actually a fictional account of a company making a transition, which is really amazing. But this book, Accelerate, is all of the research that they did in order to write things like the Phoenix Project. And it really helps you build high performance teams. And one of the big findings out of this entire book is high performance teams have infrastructure as code and CICD set up. So I fully recommend that book. Again, total 5-star review from me. All right, so moving on from dynamic web apps, this is where something new came along, and we call that the Jamstack. And so the idea is to build a totally static artifact from just pre-rendering absolutely everything and serve it out to your customers via a CDN. So any of the dynamic functionality that is contained in a Jamstack application is done by JavaScript at runtime. So that's great. You only have one deployment, and it's immutable, and nothing is really changing. We just mash all our code together, and it's the same artifact that's going to be deployed everywhere all the time. That's great. But when it comes to dynamic functionality, we have to outsource that to providers on the back end. So anything that's not part of your core business competency, a typical example is something like using Auth0 for authentication. You don't want to have to worry about authentication. So you're going to pull something in that is going to do it for you. So it allows you to focus basically just on your site and pull in any other additional functionality from outside. And that's great. That's an architecture that works really well. Taking a look at what the logical architecture, it comes out pretty clean. In fact, it's really just a 2-tier architecture. And that's an even older architecture than what we had with the MVC dynamic web app. And that's the typical client server. So we end up putting all of our application logic on the client, and then we make API calls back to our server in order to do any kind of dynamic functionality. Oh, that's really nice. That looks, from a logical perspective, makes a lot of sense. When it comes to the physical architecture, it turns out to be different, but still pretty close. Since we end up mixing our business logic and the presentation code into one one artifact, which goes on the client. And then we use our network calls to make these API requests to all of our backend services. So what we're seeing is that's okay. And it means we're only deploying that static asset. So that's the only thing it's really under source code control. And typically that static asset isn't even under source code control because it has to be built into that static asset, which is then deployed. But at least we have a git commit or some other tag that we can refer to that built that static asset for us. So we can reproduce that. But what you're seeing is that many other pieces of the architecture are not under version control at all, and nor are they even under our control, which can get to be a bit problematic. I don't know, has anybody run into an issue where one of your downstream providers has completely changed things on you and broken your application? I know I have, and those are some of the problems that you run into when you're deploying Jamstack. So taking a look at some Jamstack trade-offs. Now, okay, these are just trade-offs. I am not saying that you shouldn't use Jamstack. In fact, I've used Jamstack on a number of different projects myself. I just think everybody should consider what your use case is before immediately reaching for a Jamstack solution. So the first thing that I would bring up is that the builds are slow. And they only get slower the more code, the more data that you add to your Jamstack application. I once ran a very large internal developer documentation site for a company that I worked on. We were using a Jamstack solution. It was working great, but as the site got more popular and more teams were added to our site because they wanted to use this functionality, the build got slower and slower. So much so that we had to start breaking up the build into its own silos. So only pieces of the Jamstack site were getting built and deployed at a time. So that ended up being kind of our own homegrown solution, and it was a fun project to work on. And I know that a number of the Jamstack providers give you this type of incremental build functionality, but that's something that you're going to have to pay for. So that's something that you have to think about when you're picking these solutions. Also, Dynamic is kind of a second-class citizen with Jamstack. So it's not a full stack. It encourages like spinners, progress indicators, loading screens. So you'll see usually your Jamstack page loads, and then there could be a spinner as a portion of the page has to be dynamically rendered from an API call. And so it's only really after that initial render where you get all of your information down, any kind of additional things to add on to it are a bit clunky. So you have to worry a lot about the network connectivity, security, privacy. It's difficult to make API calls with Jamstack because how do you hide your API keys? How do you secure those kind of things? Those are things that you have to think about if your Jamstack is going to be moving from static to dynamic functionality. And when it comes to things like cloud functions, again, second-class citizens, these things are not immediately supported with most Jamstack solutions. There's a complex ecosystem of libraries and tooling services, and they all need to be glued together. That gets to be very difficult because you're dealing with a lot of different tools and plugins, and each one of those is on its own release cycle. They tend to most folks tend to follow Semver. Some folks don't, releasing breaking changes under, patch releases or minor releases when they really should be doing a major release so it doesn't completely break your system. So when you're giving up control by adding in so many different plugins, this is kind of one of the things that you run into as an issue. And then, of course, things like Sneak is required in order to make sure that all of your second-class dependencies or second-order dependencies are not running into any security issues as well. And when it comes to taking all of these different pieces and transpiling them into a single static asset to be deployed, that's pretty complex. I mean, I never want to write another Webpack configuration for the rest of my life. And I know there's other tools that do this for us as well. But this kind of stuff becomes, just unplanned work because things break. And it makes maintenance a bit of a chore. And it really creates this kind of asymmetry between the infrastructure and the code as well. So I know I just said, yes, you should use Jamstack when the situation is right. And then I just completely slagged it. So, sorry. Anyway, I think Jamstack is a wonderful tool, and it's one of the tools that you should have in your tool belt. I just don't see it as a solution for every particular application that we're wanting to build. I think it's really great for static documentation sites, and it works incredibly well for that. But if you get into personalization, where you have to do a per user personalization, that's where things start to fall down for me. So if you're approaching a documentation site with that personalization in mind as kind of like a fast follow after your MVP, you may want to start thinking about these things a lot earlier and perhaps grab a different tool. Anyway, there's this thing, it's called the Rebound Effect. Some folks may have heard of it. So basically, in conservation and energy economics, the Rebound Effect is when this new technology comes out and everybody's like, yes, this new technology is going to, it produces so much more energy, it's so much more efficient. So we're actually going to save energy by rolling out this new technology. But what actually happens is it's a reduced benefit, or not as large of a benefit as we expect, because this efficiency makes energy cheaper, which makes more people use the energy. So that is kind of sad. I mean, we've kind of seen that with cars. Basically, now that cars are more energy efficient, they don't require as much gasoline to go the same distance as they did 20 years ago. We thought, hey, this will be great, we'll end up using less gasoline. We don't use any less gasoline than we used to. We probably use more because it's cheaper for people to drive. That's just one example of the rebound effect. And so I'm trying to coin something which I call the JS rebound effect. And that is the expected gains from any new JavaScript framework. It's always less because of the amount of JavaScript that actually ends up deployed on the client. So this amount of JavaScript diminishes the beneficial effects of the new technology and sometimes makes it worse. I like to use the example. It's like, if you see me in the pool and I'm drowning, I don't want a cup of water from you. That's not going to help. You do not pour more water on me. And so that is something that I think a lot of people think like, hey, we've got this problem. The page is slow. I know how we can fix it. We can add a JavaScript framework on top of it so we can add more JavaScript to the page, making things worse. So be very careful when you're picking your dependencies. Sometimes you're just actually really adding to the problem. And so where I want to make a turn at the 20-minute mark here is taking a look at a different approach, and that is the functional web app approach. So basically, the entire thing is HTML first. So what comes down, what makes a functional web app is the first load of the page in your browser is completely functional. It's HTML first. It doesn't require any JavaScript in order to load and be used by the user. So any kind of dynamic personalization that needs to be done is already done on the server and delivered to the client immediately. And then accessibility is a top priority there as well. So the HTML that ends up on the client is already working. So if you have any issues with the network or an old browser, you don't need JavaScript in order to render these pages. They're already usable when they end up at the client. That doesn't mean you can't do progressive enhancement and use JavaScript to make the page better. But the most important thing is to make sure that that first page load is completely usable, even if the person has JavaScript turned off. And everything is cloud function centric mode. So all of the kind of things that you need in order to build modern applications, whether it's queuing, eventing, or cron jobs, is all built into the cloud system. And as well, we have on-demand databases, which is really what makes this new kind of dynamic web app approach possible. I've done some benchmarking of a number of different databases. I'm not going to name any specifically, but some of the old traditional databases where making a connection to them requires sometimes 30 seconds, which I'm like, wow, that's a long time in order for a connection to happen. So that kind of makes it impossible to do dynamic web applications using those older style socket-based databases, because honestly, nobody's going to wait around 30 seconds for the connection to happen. Now you're saying, well, what about connection pooling? But if we're looking at a cloud-centric thing where everything is running in cloud functions, those functions tend to go away after a period of time. So somebody is going to be hit with that 30-second penalty. So what we're looking at is any of the cloud providers have wonderful on-demand databases like DynamoDB, like Cosmos DB on Microsoft. Those things provide like single-digit millisecond latency. So the amount of time in order to connect to the database and retrieve data can be like 5 milliseconds, and nobody's going to notice that, which is incredible. And then, of course, we have declarative deployment. That's the last pillar. And we need to explicitly define everything using infrastructure as code. Now, there's a bunch of different ways to achieve something like this, whether it is CloudFormation or Terraform, but being able to deploy all of your application, the business logic, the presentation layer, all of the specificity of how much RAM you should be using, how many servers, et cetera, should be checked into source code control as well, so you can easily reproduce it. So our functional web application logical architecture looks something like this. Basically, your presentation layer and your business logic are done in cloud functions. Now, they're not in the same file, so you don't like mix everything together using a build step, but basically your view layer and your business logic layer run in cloud functions, and they're talking back to your like your on-demand database. So I don't know, you folks are, I don't know if you're even hearing me at this point, but what the heck? You're probably thinking this is a terrible idea, and yeah, it does sound pretty crazy. It's pretty wild from what we've usually been looking at for building applications for probably the past 5 to 8 years. But here's the thing, it actually works. I know, it's nuts. Now, if we take a look at what the physical architecture or something like that looks like, it's really quite similar to the logical architecture. So there's still a CDN there. So you're able to do a lot of caching at the CDN layer, and you have static assets so that if your web application has a build step and you need some place to deploy the static assets, you can do that. You don't have to dynamically generate everything. And especially, you don't want to dynamically generate every image that you have in your application. So static assets are used. I mean, you could dynamically generate every image. So one of the things that we've seen is that you can have a cloud function that will dynamically generate an image of the correct size for whoever is requesting it. And then that gets stored in your, your S3 bucket or whatever cloud file system you're using. Anyway, that's a digression. So all of this functionality can scale out horizontally as you need it, and it talks to a backend database. So the nice thing about this is your deployment is the entire thing. So you get this declarative, fully deterministic artifact. If you ever need to roll back to a known good state, then you can do so with a high degree of confidence. So every deploy is like a git commit. So exactly what is on the staging environment, what's on the production environment. If you see any issues, you can just revert to an earlier git commit and you're back to something that's known and working. You don't have to worry about there being any kind of application drift because somebody has gone into the console and changed a few things or manually edited one of your cloud functions. So you do everything through CICD. Now, if you look at the two things side by side, you can see which parts are deployed, which parts are talking to the database, the things that you have control over and what you don't have control over. So with Jamstack, basically you're just deploying that static artifact. Whereas if you use the functional web app pattern, you are deploying everything. So you have a much better control over what's going to be delivered for your customers. So some advantages. The first thing is you have the power of the entire stack. So it doesn't matter what cloud stack you pick. You have access to all of these things. It makes things just incredibly powerful. I actually find things to be way more fun. I spend a lot less time maintaining code and running into breaking changes, and a lot more time actually shipping new functionality. I'm going to be probably a little unpopular here, but I used to use React quite a bit, and I really did believe it when it said that, hey, we're going to really improve your developer experience. And for a while, I found that to be true. It really did help me build a component model and really help me accelerate building some applications. So I was happy with it for a while, but I don't know. We went from create element to, higher like class components, functional components, hooks, like things just keep on changing. And there's these breaking changes in React that kind of need me to rewrite my application every 12 to 18 months, which gets to be a bit frustrating. So focusing on this kind of cloud side of things and, building things from HTML first perspective and enhancing with JavaScript instead of immediately going to a JavaScript framework really helps me focus on building stuff and not chasing breaking functionality. And then when it comes to it, it's very inclusive. It's fast for our customers. Anybody who's coming into the page already gets a working page. There's no waiting for a spinner in order to talk to a backend database in order to hydrate things. Things are immediately working as soon as we get there. So none of that stuff is hidden behind any kind of dynamic spinning or content or things that aren't going to load. So hey, now what about? So obviously there are downsides to this type of architecture. So let's dig into them a bit and some of the things that you can do in order to mitigate those problems. So cold starts. So anybody who's built cloud functions, you're probably aware that there's the cold start penalty. And for those of you that aren't, there's a quick little explainer. A cold start is the period where you hit a particular URL and there is no container that's already spun up in order to do the work for you. So the container has to be spun up, your dependencies have to be installed, these dependencies have to be interpreted in the case of a Node or JavaScript runtime. And then you finally get into the portion where you're executing the code that you want to. So that portion between spinning up the container and interpreting all of the code that you need to run, that's the cold start. So how bad is a cold start? Now, we've known for quite a while now that a large code footprint is what correlates to longer cold starts. A lot of the cloud providers have done a fantastic job of spinning up new containers, of installing, unpacking your code. And it's really the runtime, which is taking the most amount of time in order to parse all of your code. So if you keep your payload side, that is the amount of code that you need to parse, below 5 megabytes, that will keep the cold start under a second. And a second is still too long. But frequently that cold start is less than 200 milliseconds. So the key to reducing the cold start penalty is small single responsibility cloud functions. And that's how you combat it. There's the fat lambda pattern, which personally I'm not in favor of, which is where you just kind of push everything into one lambda and let it handle it. That's a really good way to hit like a really bad cold start penalty. I know a lot of folks will take an Express app and then just kind of wrap it into lambda, and then they're like, job done. We don't have to do anything else. That's a good way of running into cold starts. I think that's a perfectly logical way of taking your Express application and start decomposing it into multiple cloud functions. And that way you get away from a lot of the cold start penalty. But anyway, what I'm trying to say is keep your functions small and single responsibility. You won't even have to worry about cold start. Now, the database story is still a bit emergent. There's lots of DBs like Dynamo, Cosmos, PlanetScale, Fauna. Those are all great options with great performance, no matter how much data you have. You won't need to think about your data layer anymore. And I honestly don't want to. I was able to successfully avoid taking any kind of database courses or training in my career. And so far it's worked out. When it comes to a lot of these like more modern databases, you really don't even have to think about the data. You just drop it in there and you can get incredible performance back. If your application becomes so successful that you do need to hire a full-time database consultant in order to take care of these stuff, congratulations, good job. That is going to take quite a while to get to that. So declarative infrastructure as code is often very complex. Cloud formation can be a bit scary, so much so that at Begin, we wrote our own terse format called Arc or Architect. And there's an open source project that makes dealing with cloud formation a lot easier. I will show you an example in the not too distant future of how we have an app with a very terse format. I think maybe there's 40 lines in the app configuration file, and that generates something like 1,200 lines of code in CloudFormation. So yeah, there's definitely tools that make dealing with infrastructure as code a lot easier. Architect is one of them. You can pick one of your own, but definitely you want to look at something like that. And basically, you kind of need to go all in with one cloud provider. So a lot of folks are worried about that because it's like, oh, they're worried about vendor lock-in. And yeah, that is a concern. But we found that things are not very portable between the different cloud providers as currently. An AWS Lambda is not the same as an Azure Cloud Function. It's not the same as a Cloudflare function. So if your primary goal is to be portable between different clouds, then you should probably run Kubernetes instead. What we found is that picking a cloud provider and going all in with it has made us like way more productive and extremely happy. In our case, we've picked Amazon, AWS, and again, really happy with that. Kind of the benefits we find with AWS is that, well, one, they're not going anywhere. We don't see that happening. And they really don't ship breaking changes, which is something that I really have to applaud AWS for. A lot of the reason that they have 200 different services when you log into the console is because instead of shipping breaking changes, they'll just create a new service. And that's up to you whether or not you want to migrate to the new service or stay on the existing service that you're using and then never have to worry about any of breaking changes. But even when it comes to their SDKs, there's not what you would call any kind of breaking changes in that as well. And that really helps reduce a lot of the unplanned work that I was talking about earlier. All right. When it comes to functional web apps, there is a growing ecosystem of things that provide this. You can take a look at OpenJS Architect, which is the open source project that I work on. AWS has SAM, Azure Functions, Begin is a company that I work for, Cloudflare, Deno Deploy. They've really had a great year. They've put a lot of new things out into the world, and they're super useful. And then, of course, the Google Cloud Platform as well. So I may have missed a number of different companies that are doing this. And if I have, please let me know. But basically, you can use any of these things as long as you start with Cloud Functions, deliver HTML to your clients, and then progressively enhance it with JavaScript. Now, has anybody actually done this in the wild? And it's like, yeah, there definitely are companies that use this paradigm. Kind of one of the biggest was the BBC. A number of years ago, I think they started pre-COVID, and they've definitely finished the transition. They went from like an old container-based approach to having all of their BBC News, everything generated via Cloud Functions on the fly. So they've completely switched over to a functional web approach. Other companies like a Cloud Guru and Bustle do FWAs as well. And of course, Begin. I don't know, there's the saying, eat your own dog food. So obviously we do that, but I prefer to think of it as drinking our own champagne, because that's a lot tastier than dog food, in my opinion. And again, if you know of any other companies that are doing an approach like this, please let me know. I'd love to hear about it. So, all right. Comparing, static apps with functional web apps, static apps are great, especially if you don't need any dynamic content. But once you do, that's when you have to start looking at other approaches or different architectures. So we really want to look at, having HTML first, and then that makes things way more accessible for folks. And you probably aren't going to need that fancy JavaScript framework in order just to deploy HTML down to your clients. Everything is Cloud Function centered. So that's your entire development model. Now, one of the things that people don't like sometimes about Cloud Functions is not having a local development environment. The Architect open source framework also allows you to build locally. And that just makes the whole, writing code, debugging, testing loop a lot quicker than having to deploy every change out to a cloud provider in order to see what you've screwed up and what semicolon you've missed. So yes, the Cloud Function development model has gotten a lot better. Managed databases built in is super, super useful. This makes your life so much easier just by being able to get that sub-millisecond time in order to retrieve data from it. And when it comes to the infrastructure as code, you need that kind of explicit declarative deployment. Without being able to say, this is exactly what I have deployed to the cloud, you're going to get lost in there. So we really recommend using infrastructure as code for anything like that. Okay, well, I am going to attempt to do a bit of a demo. Let's see if this actually works here, because Zoom is always fighting me. All right, so I have VS Code back here. So I'm just going to run npm start here. So we'll get our test application up and running in the background. Okay, so you can see it's running at localhost 3333. Again, you can see how ugly this application is. Please do not take that as a knock against anything that I'm using. I am a terrible designer. Pro tip, hire a really great designer to work on your web application. Pro tip, hire a great designer, or sorry, marry a great designer, because they tend to come cheaper that way. I'm still looking for one of those, actually. If you have any leads, let me know. So let's just dig into what I was talking about with the ARC format. So, sorry, working on a different screen here, which makes everything a little more difficult. So this app.arc file, what we're doing here is we're setting up our new application. We're telling it we want a static bucket. So this is telling CloudFormation, AWS, that we want an S3 bucket. Fingerprinting is true, which means that every time we go to deploy the application, we'll generate a hash to the end of all of our static assets so that we can do some cache busting. And the folder is public. And basically that means anything under this public folder will get deployed to our S3 bucket. So when it comes to HTTP, each one of these things is its own cloud function. So I'm able to, get my index, all of these players, games, seasons, etc. So when it comes to this application, all of these things are done by different cloud functions. So if we take a look at spares, I'm asking for /players with the type of spares, and that is just coming right from here. So all of these things are set up for us when it comes to what the code looks like for that under HTTP. And let's look at, that's post players. Let's just look at get players. We just have a very small cloud function here. And basically, I have this set up to our database, which is just doing a very quick query for us, but it's like, get me all of the full-time players, or if I'm asking for spares, get me all of the spares. And then my render method, where I'm just sending back all of that table using, in this case, I'm actually using web components, which is another fun thing that we can do as well. So we can server-side render web components so that anything that ends up on the client is already usable and it's just plain HTML instead of needing to be hydrated. All right, but getting back to that ARC file. And when it comes to like bolting on other things like events, so anytime an event happens where I need to find spares or send an email, or we have these scheduled jobs, which are basically crons, which, I'm creating a reminder. So in this case, every Wednesday morning, I send out a reminder to people that, hey, we have a hockey game this Friday. For the weekly roster, it's on Friday. There's a little script that just goes ahead and creates, the two teams for me. So all of this application is just for me to scratch my own itch, just to make life easier for managing a hockey team that I run. And then getting down here, tables. So you're just declaring I have a players table, a games table, a seasons table, and an invites. Anyway, not to worry about what the individual tables are, but all of this stuff sets up like DynamoDB tables for me without me having to write anything else. And I can create some indexes as well. So I think I said that was about 40 lines. I guess it's grown quite a bit as I've added functionality to this application, but you can see we tap out at about 88 lines of code. For specific AWS stuff, we're saying deploy to US West, use the ARM64 and Node 16. So that's 88 lines of pretty easy to read file. Now let's take a look at what the CloudFormation would look like if Sam. So I think I buried the lead on this before because we talked about it. So we are writing some pretty nasty JavaScript, which is, or sorry, some pretty nasty JSON, which is basically just almost impossible for anybody to write this by hand. And if we scroll all the way down to the bottom, we can see that it is just, 1764. So 1,764 lines of CloudFormation that you would have to write by hand versus 88 lines in the terse format. So I'm not saying that you have to use Architect, but what I'm saying is you should really use a tool that makes generating this CloudFormation stuff a lot easier because the chances of you writing this by hand without making a ton of different mistakes is it's zero. I think zero, I think is what I'm really trying to say. So that makes your life a lot easier by doing something like that. So that's kind of a quick overview of why we would use something like Arc instead of just writing CloudFormation by hand. This particular application, you can see it's ugly. I know I already explained that, but it's pretty usable. So let's go ahead and like add a new person to this. Let's call him Guy Incognito. If you're fans of The Simpsons, you'll probably get that joke. And we don't need a phone number for him. He's actually a forward, and let's just go ahead and save that. So immediately into the database, Guy Incognito is added. Everything worked pretty great. So the other fun thing about this is, let's just go ahead and, oh, sorry, my bad. Let's just bring up the web inspector and then do run command. And let's just disable JavaScript altogether. So JavaScript's off right now. And let's add somebody else. Player 2. And let's make that person a defenseman and save. So we just added a new person to our database without needing any JavaScript whatsoever. So that's kind of the progressive enhancement that I'm talking about when it comes to these functional web applications. So if we look at things by just deploying HTML directly to the client, using web components in order to provide default functionality and progressively enhancing it to make things fancier, we can go a really long way without needing any JavaScript at all. And that's going to make your application super performant. It's going to make it very accessible to people. It's just a really nice way of building things. So that's basically what's going on there, folks. And now if I can turn JavaScript back on, because I have a feeling that my presentation will stop working without JavaScript on. But hey, what are you going to do? All right, so that is the very short demo. If you want to learn more about anything that I'm talking about here, you can always go to fwa.dev. That's kind of like a white paper on the architecture itself. You can check out Architect, which is the open source project that I've used to build the application. And if you want to start deploying FWAs, you can use begin.com, completely free to get started. All you need is a GitHub user ID, and you can start deploying to Begin. And please, I like to know how wrong I am. So please contact me on Twitter at MacDonald. And I just want to thank all of you for spending time with me this morning. I wish I could have been in Florida, although it's pretty hot up here too. So I'm not missing the heat. So anyway, I'm going to unmute things, and folks, if you have questions, please let me know. I'm going to try to unmute.
Yep. Anyone have any questions?
I'm curious if that architect tool makes sense for a project that doesn't necessarily have a web front end.
Yeah, no, you can definitely use Architect. So if your tool, if your application is basically just a backend API where you're just retrieving data or doing some headless functionality, you can use Architect to do that as well. One of the patterns that we tend to use when we're building our applications is have a kind of, in the same way that Express has like different functions to handle the same thing on different routes. If the content type is equal to JSON, we'll just return, if the content type of the request is application JSON, we'll just return JSON back to the person. But if it's HTML, then we'll return an HTML page back to the person. So that way you can have a backend API as well as a front end UI using essentially the same code. But if you don't need the UI at all, you can easily build API applications using Architect as well.
Yeah, if you can speak up a bit.
Yeah, can you hear me okay?
I can hear you now, caller. Go ahead.
Okay, so if I was to have an architect or a system that has a on-prem database, would you recommend doing this like with an event-driven architecture or what recommendations would you have to try to implement that if you still have the on-prem database?
Oof. Yeah. The issue there is the on-prem database. What is the latency to connect to this on-prem database? That's really the issue that I would see there. Yeah, I would probably could the cloud could your cloud provider even connect to your on-prem database? I think you would pretty much have to put an API that's accessible from the outside world in front of your on-prem database in order for you to be able to access it. That way you shouldn't need to worry about spinning up the connection pool. It's already available, so that would get away from your cold start. That's a fun problem. Can you hit me up on Twitter? I'd love to talk to you a bit more about that. But yeah, you could pretty much do the UI and the business logic in Cloud Functions, and then you would need to connect to a completely different server in order to access that on-prem database.
Yeah, sure. Thank you.
No problem.
Yeah, go ahead. Yeah.
So how different is this architecture pattern opposed to an Next.js application running server-side code on for every route?
Could you hear that okay, Simon?
I think I got it. It's like, how different is it from a Next.js application that's running a code for every server-side route? Next.js is a wonderful tool, but generally a lot of it is based, and it's been a while since I plugged into Next.js, but I haven't seen too much of their server-side offerings, but a lot of it is based off using React in order to build things. Yeah, I don't really feel qualified in order to answer this right now, but I'm gonna make a note, and how would I get back to you on that? Because I don't want to slag anybody that I don't know. I know that is not a very satisfying answer, but I've been heads down working on some pretty fun stuff this past year, and I haven't really been keeping up with what Next.js is doing server side.
That's all right. I'm just curious.
Any other questions? I think that's it here, Simon.
All right, that's great. Well, I hope everybody enjoys the rest of their conference. Go have some fun with me, and I swear, folks, at least dip your feet in the Atlantic Ocean. The last time I was at a conference around that area, not one person from the conference dipped their toes in the Atlantic Ocean, which I thought was just absolutely ridiculous as somebody who grew up on the East Coast of Canada. So I know there's a pool, and I know they deliver drinks to poolside, but at least try the ocean. That's all I want for you. That and look at infrastructure as code. All right. All right. Thanks so much. Thanks for having me, folks, and have a great day.